My name is Rob Young. I'm product manager for the MySQL server. I came over with the Sun acquisition and more recently with the Oracle acquisition. It's my pleasure to introduce a couple of good friends of mine. Jeff Freund with Clickability. For those of you that know Clickability, they're with the content management. They're probably one of the more premier names in that space. They're headquartered here in San Francisco. And Jeff has been a friend of myself and the engineering team that has developed the product that he and Mark are going to talk about today, the Enterprise Monitor. Co-presenting with Jeff today is Mark Matthews. He is the senior architect on the Enterprise Monitor product. It's been my pleasure to work with Mark for the last 4 years now on this product, and I think you're going to see pride and ownership in this. This is a really cool product. It shows you things that about MySQL that you never thought possible, and I'm really honored to be here and introduce these guys. So without further ado, here's Mark and Jeff.
All right, thank you, Rob. So we're here to show you the use of Enterprise Monitor to do some performance tuning and analysis and be more efficient with it. Rob already dispensed with the pleasantries. Actually, all things should be pleasant, so we should be all right. You'll get used to this after a while. You've probably seen this slide multiple times today, so read, follow, understand the directions. If I name a date, it's not a contractor purchase thing, okay? There's not that much forward looking in here, but just in case I were to blurt something out, this is up there. So real quick agenda. Performance analysis, when and why, or why and when, depending on how you want to look at it. Particularly about data store performance issues are what we're going to be talking about here. The classic approach to finding them with MySQL. If you're new to MySQL, how many people are old hats at MySQL here? Does anybody want to raise a hand? Okay. How many people are Oracle users and they just wanted to see what this MySQL thing is all about? All right. Out of the box, it's going to be a little bit scary. You're not going to have all the tools you're used to sitting right in the database, but we're here to help you out. And you'll see kind of how nuts and bolts you have to get sometimes if you do it yourself. And then we'll show you how you do it if you happen to use MySQL Enterprise Monitor. We try to make some things a bit simpler for you. And then, that'll be a short demo, but then I'm going to turn it over to Jeff here, who's going to show how he's used the product. He's used the product to actually kind of do this whole life cycle approach to performance management. And a quick wrap up. Feel free to interrupt whenever, but we'll try and blast through some of this front material and leave the back end open for questions, okay? But if you want to ask something, feel free. So when and why? A lot of people think that performance analysis and troubleshooting and tuning is either right before deployment or for the ops guys. So real quick survey, who's an ops here? All right, who's a developer? How many developers use any performance tuning tools with their code? Oh, so I see a few, so that's good. Yeah, and the ops guys, they hate the ones that didn't raise their hands, all right? So even the team that builds this product, we are big proponents of performance starts at the beginning. It starts at development. It starts with looking at performance while you're developing the product. It's looking at performance during QA. It's looking at performance during pre-production. And it's looking at it in production. And it's the full life cycle. And there's various reasons. You can catch different things. You're going to have performance requirements brought from your stakeholders during development. You're not going to know whether you can meet all of them, but some of the bigger ones you're going to know pretty soon in your development cycle. So integrating it in your development cycle early is great for that. There are certain design standards. Certain queries you're just not allowed to run. How do you know if your software is doing that? And if you haven't used a framework or some part of your stack and you're writing everything by hand yourself now, when you get into a stack and somebody else's components, you're going to get surprised, especially as a developer. When you see what some of that stuff's really doing to the database when you call just one line of code, you'll be amazed. In the QA cycle, you have the issue of, they run into a problem with performance under load because they're load testing. What's going on? So having these kind of tools available at the QA cycle is great. And basically in production, I think the thing you're trying to build is a pulse of what this thing is like deployed. What does it feel like as it operates day by day? What does the thing look like when it's kind of out of its normal performance compliance environment? And when it is, then how do you know what happened? And then, of course, there's a proverbial fighting fires for the ops guys, the page in the middle irate and angry people on the phone. So some of those things that can cause you to get that page, the data store specifically, this tool is centered around MySQL database. It doesn't necessarily go after application level problems. You know, you have the missing or dropped index, too much contention, suboptimal configuration. Somebody twisted some knob out of the box. They didn't know what it was for. It looked cool. It sounded like a go fast button, and they turned it on and didn't work. But then there's some sneakier things that are really hard to find with a lot of the stuff that's out there with MySQL today. There's a query that executes way too often. It's not long, it just executes a lot. So it doesn't show up in slow query logs, it doesn't show up a lot of other stuff, but it executes 10,000 times a minute. And how do you know you're getting those and where do they come from? Even trickier ones, statements executed in vain. They do absolutely nothing. They update no rows, ever. They're always a syntax error. I've seen those applications where thousands of times a minute, it's the same query that is a syntax error. So it's taking up network bandwidth to raise errors. Statements that touch too many rows, where you think it's updating one and it updates 200, and the app still functions just fine, but it's doing more work. And one that's killed more than one of our customers is somebody in deploying an app into production where the production guys don't know about it. So they do that, or they deploy a feature and didn't really talk much about it and it kills performance. So here's how you find out about some of these things the classic way. You get a page. This happens to be Nagios, but yeah, service is still up, it's not meeting performance requirements. You get a bunch of stuff there and you're like, oh, well, I have a time when it happened, that's about what I have to go on. So then I go to my favorite tool, the graphs. This kind of gives me the pulse of what's going on in my system over time. I look at that and say, oh yeah, there's something creating extra temporary objects there. It's around the same time. That's got to be the culprit. Being a DBA in production, well, that could be a couple of things. Temporary objects, I bet you somebody's doing, an order by or a group by, and it's not indexed. Well, let's try the slow query log. Query's not using indexes. Nothing in there. Query's not slow. It's just probably executing a lot, causing that. So if you're lucky, the general log's turned on, and probably it's not in the production server because the I/O load it generates. But let's say you have it. Okay, so you have 112 megs or 2 gigs of queries to deal with. Anybody here good with awk, Perl, and do a roll-up and all that stuff? All right, yeah, that's a lot of fun though. That's what you want to be doing on a Friday night after you got this page. But there are a lot of tools for post-processing the log. There's, MATKit, MK Query Digest can go through and look at this. And what you end up with is a culprit similar to this one. Select blah, order by, I bet you that order by goes, on something that doesn't have an index. So there's not a covering index for it. Okay, fine. The magic thing though, remember those framework and stack surprises? Your developers are using an ORM. So your query looks something like this. One can barely read it, but here comes the kicker. How do we find and fix this? Okay, we intuitively know it's probably missing index. You can log into the database, do the explains, add an index. Oh, MySQL, downtime. You're gonna lock the table while you add the index, so you have to deal with that. But not only that, let's say this was a scale-out farm and this was happening on 20, 30 servers. So you're gonna log in and explain on every single server and find out where it is and what it's doing. That's a pain. So even if you fix the index, this thing just still happens to be executing a lot. How do you fix that? You go ask the developer, hey, do you recognize this query? And they'll say, I don't write SQL. Probably. I have a guy on my team who's like, that's a database problem, which is funny because he works for a database company. But anyway, that's our inside joke. So what code is executing that query and why? Remember that kicker about ORMs and frameworks. Here's the query we got when we post-processed the log or looked inside MySQL. Here's what it looks like in code. The ORM has made it easy and simple for us, except when we have to figure out how to get from that to that. How do you find that in your code? And not to pick on ORMs. We use one in our product. It's great. It solves a lot of problems for us, but everybody has coding standards. You're using PHP, you make the query, you sprintf into it. It's broken up over multiple lines because of your formatting rules on your team. Okay, so how do you get from, well, the easier version of that to that? How do you find in the code where that happened? So once again, anybody really good with text transformations and knows how their ORM or the other stuff is turning around. These are hard to find. There has to be a better way, an easier way. And if I didn't think so, I wouldn't be standing up here today, so we're going to show it to you. So the issues with this previous approach, one, it's not integrated. You get the page. It's just a page. You got to go check some other tool. It's the graphs. You go look in there. Oh, there's a graph. I can drill down and see what it is at the graph, but it's not correlated to anything else. I can't see what queries are running at the time. I can't take it any further than that. You saw the general log stuff. It's not real time. You may have to recrash the car to get the problem. You may have to go turn the logs onto the server, go capture it for a little while, figure out how you got in that state again, get the stuff in the logs, and then post-process it and find it. And this really limits the types of problems that can be found and fixed. And it quickly becomes complex. And the other thing is the analysis bug here often stops the MySQL server itself. Everything, all these tools in this approach, the timings and what you can fix all stays with the MySQL server. You're not seeing the real response time out of the app. You're not able to figure out what in the app is causing these things to happen. So we think, well, we don't dress like that. So, yeah, we're learning. See, I'm wearing slacks. Normally I do like in jeans. So we think the better way is Enterprise Monitor based approach. So what is MySQL Enterprise Monitor? Is anybody using MySQL Enterprise Monitor in this room? All right. Oh, yeah, Rob is. Okay, I know this guy is. Did you raise your hand? Okay. So it's a tool that provides proactive monitoring and alerting for your MySQL environment. So it's got part of the integration story right there. It's monitoring and it's alerting. So you have performance trending and history and alerting all in the same package. Part of the MySQL Enterprise subscription offering. So if you're a support customer, then you get this too. And you deploy it in your environment. It's not software as a service. In this case, it's behind your firewall. It all lives there. We think it's more efficient because, like I said, it combines the analysis, so the performance over time, alerting and diagnosis. It also has this advisor service, which is a series of rules, a rule engine that runs against your instance all the time as data is coming in, and when it finds things it knows can be problems, like those bad configuration values, it will flag them for you and say, hey, you shouldn't have touched that, or hey, maybe you should go look at this. From the performance analysis, it can find more of these data store killers. In fact, I think it can find just about all of them. It essentially becomes a data warehouse of your MySQL server's performance over time, including what kind of queries it's running. Jeff will show you a little bit of that in a second. And it goes nearly full stack now with some of the stuff we've announced lately. So two of those where we first introduced query analysis. And what we had was this, our agent that you deploy MySQL database servers. There's a proxy in there. So any application speaks MySQL to the proxy siphons up some performance data and passes the real query under MySQL. And performance data goes to MySQL Enterprise Monitor dashboard. It's great because it works for every application. There are some shortcomings in that it does become a single point of failure, so you have to work around that by doing sampling or making it HA. And it does have a latency impact on a lot of applications. So the next version of things we came up with are what we do in 2.2. Where you still have the enterprise agent with MySQL proxy, but you can get plugins for JDBC or .NET, which actually siphon off the query performance data out at the application. And they're not in the middle, they're on the side looking at the data. So if that plugin fails for whatever reason, doesn't bring down your app, it just stop reporting data. And since it's a performance tool, not auditing tool, we live with that. So your queries go just like they used to before, and the performance and some of the configuration data go back and forth in between the plugin and the enterprise manager. And the thing that's coming in 2.3, and this is that forward-looking thing we're talking about, calendar year 2011, is that you'll have plugins for PHP or C that talk to a component in the agent called the aggregator. Because PHP and C are often short-lived processes, they can't take time to aggregate the queries. They just fire everything off to this aggregator. It does the same thing the proxy does or the plugins here do. If you don't happen to use PHP or C, you have some other application language you like and we haven't gotten to it yet, you can integrate your application with the aggregator and do the same thing. You'll be responsible for grabbing where the call stack stuff happened, but it's just JSON and HTTP between the two. So that doesn't sound so bad until you think of the typical scale of architecture of MySQL and you multiply all that stuff we talked about by scale. So let me take a second here to show you just one example of what this looks like in real life with the product. So here we have the Enterprise Monitor. It's actually running here on the laptop. And one of the things I wanted to really talk about So you have the whole deal with scale. We use replication. There's different topologies. You know, our product discovers all that, figures out the topology, presents it in the UI the way it is deployed. So you don't have to figure it out. Yes? I'm running 2.3, but everything but the PHP and C is 2.2. So if you have 2.2 today, yeah. The UI doesn't look fundamentally different in 2.3, other than the logo is a bit different and it says Oracle on it. So you have all of your servers sitting over there. You can navigate between them. The thing that's interesting about our product is that when you work at this level, so all servers, this is showing me CPU utilization across, averages across all servers. It's already grouped and rolled them up. And so then you can do it by replication group or arbitrary groups that you decide to make. Really quickly, I wanted to show you, there's this whole set of advisors, the rules that kind of back you up. So they're in there. So that's not necessarily performance analysis, except that it covers that one of, you know, somebody turned the knob that shouldn't turn. It will watch out for you for that. So what I wanted to show you was the whole integrated portion. So instead, assume you got a page from mem, which would take you to this dialog. So we can alert, we do SNMP traps, we do SMTP. You know, we have short messages that go out to SMS. The thing that was new in 2.2 is that if you see this little here, whenever you see this little magnifying glass, if an advisor is query related, it will actually take you over to query analysis and show you what queries were running right around the time that it noticed that thing. So we're pretty sure that this was what was causing that alert to go off, because it's the one with the highest count. As part of the data warehouse portion I was telling you, if you look at everything we roll up, you know, execution counts, how many errors it's had, warning, you know, max averages, how many rows it's touched, you know, how much data it's sent back and forth. You can search on all this, you can filter it to your heart's content. But the interesting thing here that I wanted to show you is the integration. So we see that it shows that it had a table scan. We pop this open. You may have seen this part before, where, you know, it shows the query in the form of a prepared statement, just because that's how we aggregate. And you get your performance area of execution times, max min, just for this particular statement. You have the explain plan for that kind of query. So you don't have to run out to every single server and grab the explain plan. You can see right here, yeah, well, possible key is null. Yeah, it is doing a table scan. Our guess is correct. The interesting thing is here, the example query. Here it shows a particular query that was slow at that time, but here we actually show you where in the source code it was. So, dealing with the projector resolution here. If you look down here, now I know enough about stack trace because I happen to write some of this, that the interesting bit is outside of Hibernate and outside of Spring, and it's this line right here, catalog scenario, which I've made for this demo, line 54. So, really quickly, remember what the query looks like, all right, okay? There's what it looks like when, you know, your Java developer gets what's in Hibernate. You know, I found it with one click. It told me what line, you just take this to your developer and say, hey, fix this. And then he says, oh yeah, I remembered. I had a question for you. Should we cache that object? Well, then you'd be fixed. You'd say, yeah, turn that on, and we're done, okay? So that's an idealized view of it. I think I'll pass it off to Jeff here, who will show you how they use it in real life.
Okay, so the real world, I guess that's the title for this part we're talking, and we too don't dress like that either. So I'm from Clickability, and just to kind of frame what we do to help understand the challenges we're up against, we're a SaaS web content management platform. So what that means is that we have a SaaS application that our customers use to build their websites on, and we actually deliver their websites websites as well. So we're effectively hosting a customer's website, providing them a development platform to build on top of. It's a Java platform. In all, we have about 8,000 content users in the platform and delivering over 600 million page views a month. So, from a traffic perspective, it's significant. And remember that these are all of our customers' websites, and they're the ones building it. So, we have our data access abilities for them to use, but we certainly can't control what they're doing on the platform or kind of what their data looks like as well. These are a couple of our example customers. NBC Bay Area, we actually have several NBC affiliates. This is the local one. NetApp, there's the NetApp app I saw earlier. BMC Software, these types of customers. So, obviously a mission critical, type of application for them. So in talking about this and our use of the query analyzer and the MySQL tools, it's really, thinking about it in the framework of optimization maturity. And this obviously always starts at the beginning here with firefighting. So, finding those individual queries that are just bad, the missing indexes, the table scans, the things that you go and diagnose by looking at the slow log, or the process list, or explains, or MyTop is a tool we've used at times for this sort of thing. And that's really kind of the first level of optimization for us, is this firefighting aspect. The second part is what I call the tune-ups. So, we're not dealing with individual queries that are bad. We're looking at our databases and figuring out how do we make them perform better? How do we get their throughput up? Why are they running a little hotter than we would like them to, at this part of the week or this part of the day? And that's when we go in and typically we use tools like, our server statistics grabbed through Cacti, our application logs we have, so the Enterprise Monitor data, just doing log analysis and trying to correlate things that are going on in the platform. And then the real fun stuff actually starts in the last part here, so the proactive engineering. So actually getting to the point where we're not tuning individual queries, we're not tuning servers and specific dynamics in the application. We're really looking at our platform system-wide and figuring out how we can engineer to a better performing platform. And this is looking at the application level, the database level, and kind of everything in between there, even down to the actual data itself. So it's the instrumentation, that is ingrained in the platform itself, having our key metrics that we track over time to identify how changes are happening. It's about having automation and load tests, that have been developed to specifically real-world test the application in a way that we can do things and we can, again, proactively lead to a better optimization. And lots of custom scripting. I think they said graph expert, yeah, definitely one here. Not as much anymore, but that's been a big part of this over time. And what we found is, the query analyzer really provides a valuable tool that actually spans across this kind of full spectrum of optimization maturity. Starting with the identifying the query that Mark pointed out in his example, all the way through to, I'll give a quick use case of the kind of full platform proactive engineering side of things. For our deployment model with the query analyzer, there's 3 pieces to it. The first is really just ad hoc studies. So there's something very specific that we want to go look at, so we'll run a manual test. The next thing is in production. So we actually run this in production. We use it to collect data on kind of ongoing, continuous basis. And one of the really important parts for this, for us, is this pre- and post-release comparisons. So we run an agile development methodology. We're releasing our full platform every 8 weeks, which means that we have plenty of opportunities to make sure that we're doing that well and doing that right. And doing the pre- and post-release comparisons is a big deal for us. And then the last part here, which is kind of the most quickly evolving right now, is our pre-production work. So how do we do our load and performance testing beforehand in an automated way that leads to kind of actionable results? And that's really the focus of where our ongoing optimization activities are. Always much nicer to optimize pre-production instead of in production. In terms of the actual data and how we use it, Mark just gave us a quick demo of the UI. So, this is really applicable to our ad hoc studies where we want to go and look at something specific. Manual inspection of some of the data. Mark just showed me some of the new filtering tools and so on today, which are a great help in kind of weeding through things here. I'm sure you can't really see this very well, but there's a long tree of servers there that we're connected to. The next piece here is through some custom scripts that we've developed. So all this query analyzer data is actually going into a database itself. So what that allows you to do is not only use it through the UI to use the data, but really develop scripts like we did to really go in and get at the things you're looking for. So for instance, doing these comparisons, the pre and post release comparisons. We have a script that we run. We give it 2 time periods to do the comparison between. And we'll look at all the queries run, tell you the difference in how many times they were run the first data set versus the second data set. It'll highlight new queries that have emerged. And that really generates this report, this kind of release report for us in terms of database activity once the release is actually out in production. And then the final part here is integration into our monitoring tools. So Nagios, Cacti, tools that we use kind of across the entire infrastructure. And building into that so that, as part of the data we're collecting, we can be trending it in the same tools we use for everything else. We can even be alerting on it when there's some change that has happened that we're not excited about. So, taking one step deeper into the deployment model. This is a simplified view of our infrastructure on the left. So we have application servers and we have databases. To give you a sense of scale, we probably have about 150 application servers total and about 40 databases total here that we're working with. On each database server, we're actually running the proxy locally that Mark mentioned. And the way that we manage this, because the proxy is the thing that's collecting data, again, going back to the Enterprise Monitor, the way we manage this is that our application servers can really run in 2 modes, one where it's collecting data and one where it's not. So when it's collecting data, it's going to be making a database connection to the MySQL proxy on the port there, port 4040. And then the proxy is going to be routing that internally on the same server to the database. So it's still technically another network hop in there, but it's a local one. So we found that having it deployed like this, there isn't too much overhead in running things through the proxy for at least our platform. We always can go back and have it bypass the proxy as well and just go directly to the MySQL port there. And we actually control this through IP tables, so through the IP routing on our application servers. It's a really quick way to just kind of go in, flip the switch, and change it from one mode or the other. I guess one thing I definitely want to point out was, there was some work we had to put into data pruning scripts there. We generated a lot of data doing this, tens of gigabytes, a week, I think is what I ended up getting. So that was important. And then the next step here is to convert to the JDBC driver deployment framework that Mark was talking about. Looking at our pre-production environment, this we actually have moved to the JDBC driver enterprise plugin. So typically, we'll have our load test running on an application server, be collecting the data, it going to the MySQL Enterprise Monitor, and then our data analysis scripts running against it to do comparisons. Again, the data management part of this, this is more of an archiving challenge, since we want to have these be more snapshots in time. We want to make sure we're keeping all that data in the past. And the next steps here, so the first is to embed the load tabs into our continuous integration processes, so that every time a build gets kicked off, goes through the continuous integration process, gets deployed in the production server, they'll also go and run a load test and alert if something's out of whack in the database query statistics. And the second thing there is to hook it up with Nagios and Cacti, as I was mentioning. So this is our pre-production model right here. And this is what we actually use to do this little case study, which I'll present, which is really optimizing one of our internal caches. So we have data in databases. We have a Java application that's publishing websites, customer websites. And in the middle here is these little object caches for performance. So what we're going to do is try to optimize what we call our link content cache to lower the database load and measure that in terms of number of executions of a particular query that we're studying. That we know it's expensive. We can't tune it any better than it is. It's just expensive, so we want to reduce the number of executions there. And obviously the trade-off here is always between what you cache in memory and the database load. So this is a very, very simple test. And by doing it, we run our load test. We've run our load test over a 2-hour period. We do everything warmed up at first and let it go. And this is a graph of just taking this one particular query that we were looking for, and how many times it runs per minute over time. So a lot of variability here, a lot of spikes, a lot of troughs, which is related to the fact that this is a load test. So we took some real world data, ran it against the server to see what would come out. So this is the data for having this cache set with a 10-minute ETL. So this was one run. And then when we go and combine several runs together of different cache TTLs, so 1 minute, 5, 10, 20, 30, up to 60, we get a really nice graph here that shows the impact of changing this cache TTL on the database loading occurred by this one query that we're trying to minimize. So when we look at a graph like this, we typically take a cache TTL, kind of down in this period. So you get big steep gains at first, and then it's kind of leveling out. So that would be a production change, and I think by way of actually just doing this case study, I think it is a production change that's going to go out with our release next weekend. Let's see. All right. So that's it for my part. Again, I want to thank Mark and Rob and his team for putting together a great tool here. It's definitely been something of high value. We've kind of evolved ourselves from mass firefighting mode into kind of this proactive engineering mode over time.
Just stay fired up. So hopefully you've seen through what Jeff presented when we talked about that there is kind of a sane way to approach this with MySQL. You don't have to be woken up in the middle of the night and then write Perl and awk scripts to figure out where your performance problems are, and then go bother your developers and say, hey, can you recognize this query? And they may not. The big things are that the Enterprise Monitor pulls all this tooling, analysis, alerting, trending over time, and pulls it all the way through the stack, especially with version 2.3, where you're going to start seeing again PHP apps and native apps, right where the problems are at, which I think is really interesting. I mean, it was interesting. We eat our own dog food at MySQL, and the first iteration of Query Analyzer was internal. When we knew we wanted to do it as a product, but we verified it by using it on Enterprise Monitor. We wrote it before proxy was even ready. We did an Enterprise Monitor, and we learned stuff. And then our running joke inside was always, if only we had a tool to see what our app was doing in the database. And I was like, oh yeah, we'll use this. So it does make a big difference, especially when you can start to introduce this stuff to your developers. If you told your developers, hey, yeah, you're going to have to go learn to use, cacti and the sort of query logs. But handing them a line on the source code helps a lot. And with that, open the floor to questions. I think they want you to approach the mic.
So how do I get this? How do I buy this?
So it comes as part of the enterprise subscription. If you want specifics, Rob is a good guy to talk to you after the talk. But it's available for trial. You can download it and start a trial right away.
You can get it today. Go out to the MySQL.com site, register for a trial, and you can download it and start using it. So fully functioning, not doing this.
In general, this is bundled with MySQL Enterprise Edition, right?
Yeah, so if you use the MySQL for free, we got a bunch of tools wrapped around it, but if you want to get support, we have the MySQL Enterprise subscription. It comes with the monitor and a bunch of other cool stuff. Is there anything in between? Between free and paid? We don't sell this as a separate line item. Right, you have to go with the support subscription as well. Get it. So, good question though. Give this man a t-shirt.
And so just to clarify, so it's not just about getting support. I mean, so legally use this product, you have to be licensed for the Enterprise Edition.
Yes, it is a commercial product under MySQL.
Thank you.
Or the Oracle, I should say.
And we had another question in front here. Oh, okay. Yes, go ahead.
Is this patterned around the OEM, the Oracle Enterprise Manager, and whether it is or isn't, is it incorporated, can it be incorporated into the OEM stack for monitoring?
So This existed before we were acquired by Oracle and existed before we were acquired by Sun. So patterned after, no, and it's a little bit different in that it's monitoring, not management yet. But if you attended the keynote this morning, you would have seen a bullet item on Edward's presentation where it said, called out enterprise manager integration calendar year 2011. Some of the agent technology stuff we do will be integrated into EM. So if you use grid control, at your shop, you'll be able to manage MySQL that way. Whether we'll be able to pull this in there or not, I don't know. We haven't really evaluated what the featured matrix for that's going to look like, what's even possible.
And the other thing is, this product will remain a standalone product as well, because we have MySQL only shops that will never use Oracle. We have Oracle shops that will never use MySQL. So there'll be an integration, but this will remain separate as well. So if you're MySQL only, you don't have to worry about it.
Go ahead.
So if I'm monitoring multiple databases, can the repository be in just one database instead of all of the databases?
The repository is one database.
Okay.
So,
but you could have it in individual databases also, like you mentioned in the other demo.
I think so. If you're referring to our practice of having the proxy deployed on each, that was a deployment choice for us.
Okay.
But that could similarly just be one proxy server that everyone went through the databases.
Okay, that's it. Thank you.
any other questions? Go ahead. He's prolific.
This looks like a good product, and I'm thinking ahead to actually implementing it. What kind of server size do you guys use as opposed to the repository? What kind of hardware do you need to make that nimble and quick? I'm not so much worried about out of this space, maybe more about processors.
Yeah, it's going to be what you would think of as a commodity. Probably a server with 2 CPUs, 4 cores, maybe a couple of gigs of RAM. Nothing crazy. It does come back to our practices around how much data we're keeping online and so on. But it's worked very well in just our standard hardware format.
And probably our highest volume customer is knocking on the door of 300 servers. And it's still a commodity box for the whole SSDs, just because we're right in the act. But it's still a commodity box. It's not.
I assume you guys use a MySQL database
Yes.
for that too?
Yes.
And you can dedicate a repository, you can define it on an existing MySQL server as well. If you got one that started running, you can deploy people on there as well.
Yeah, and some of the purge issues you alluded to, in 2.2, we fixed a lot of that because we started using MySQL 5.1, which has a partitioning feature. So we're actually able to use partitions to just drop off the whole data as a itself rather than trying to read it. We have one other t-shirt too. And we need another question.
Just to let you know, this is just like the MySQL server. It runs on any platform. So Linux, Windows, Mac, whatever. So if you can run MySQL on it, you can run the enterprise monitor.
The service manager, it's not that limited. I mean, if it's something you would use as a normal service, so Mac, Windows, Linux, Solaris. The agents are all whatever 18 platforms or MySQL server runs on. So if you have HPUX or AX in the house,
I think about the fall,
FreeBSD, we run it.
Yeah, we did a FreeBSD. So
We give you another t-shirt. All right. I guess if you want to talk to us about that, you talk to Jeff and talk to the customer. And, thanks for your time. Thanks for coming.